Hello, let's continue our Sudoku adventure with Quartet for Blunt Instruments by Gene. So we have normal 6x6 Sudoku rules. So that means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have lopsided arrows. So yellow lines in the grid. Our lopsided arrows shade one cell on each of the yellow lines. Maybe this one. Digits on one side of the shaded cell sum to n, and digits on the other side sum to twice n, where n is the digit in the shaded cell. So if this were, say, a 4, let's do something better, a 6, then these three would sum to 6, maybe 3, 1, 2, that sums to 6. And then these two would sum to double 6. So that was a bad choice, but anyway, that would be 6, 6. But that clashes. But that's the idea, is that these sum to n, and it's saying one side or the other. So we could do it the other way. We could make these add to 6, and then these three could add to 12, which we could do 3, 4, 5, for example. So this would be one way to fulfill this lopsided arrow. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. How do we get started? Well, I mean, we can't shade here, I think. I think just by definition of the rule, we can't shade here because there isn't another side. So it would have to be a 0 in there. So shading here wouldn't work because this would be... This would have to add to... So, okay, here's my point. This wouldn't be the n. This would be the 2n. Because if it was the n, it would be the same as green. So it would have to be the 2n, which is fine. But now that means this is n, which means this adds to at most 6. And I think that's... Actually, does that work? I could do like a 1-2 pair here. That's 3. And then I could do like a... Yeah, I could even make it add to 5. Oh, but the issue is this needs to be doubled. So actually, it's not at most 6. It's at most 3. So we'd have to double it to 6. And this can't add... There's no way this adds to 3. Okay. So we can't put it here. So why don't I gray the ones that can't be our center? I think here works and here works. I don't think these two work for the same reason. All right. So one of these two is my center. Maybe there's something here that's better. So I'm going to gray the ends of all these. Maybe this in the same box is useful. So if this was my center, then this would be twice it, and this would add to it. So the center is going to be 3. So one of these two is the center, and it's going to be 3 because let's just use it. It's symmetric. But if this was, so 3 here would force this to be 6. So because it couldn't be another 3. And so as a result, 3 is the biggest we could go because we have to double it into a single cell. And then these two can add to have to add to at least 3, as with a 1-2 pair. So what we've got here is a 3 in one of these two, and then either this is a 1-2 pair or this is a 1-2 pair. So the 1 and 2 are used up in these 4. So these are from 4, 5, 6 is kind of the point. That's pretty big. And so these are from 1 to 6. Oh, wait, the 6 is used up as well. So they're actually from 4, 5 only. 6 is going to be somewhere. This is 1, 2, 3, 6. Okay, yeah. So 4 and 5 don't go on here. Because we're going to have 3 doubling it to 6, and we're going to have 1, 2. Or we're going to have 3 doubling it to 6 with 1, 2. Which means these are from 1, 2, 3. Okay, right. So do we have something similar going on here? So again, we can't exceed 3, but we could be a 2 or a 3. So I don't know which one's used. But so like a 2 here, we could double to 4, and then these could both be 1, is my point. That's just as one of the options there. Or we could do like 6 and 6, and then this could be 12. Well, no, it can't be 12. But we could do 5 and 5, and then this could add to 10. So that's an option. So actually, the middle digit is up to 5 here. So maybe we should look at this column instead. So we could actually do some math here. So whatever our center digit is, and wherever it is, n, right? Whatever n is, the line's going to add to 4n, because on one side we have another n, and on the other side we have 2n as a sum. So n plus 2n is 4n. And so this is divisible by 4, and it's going to either be, I mean, it's not going to be 4. It's not going to be 8. In fact, what's the minimum? The minimum is 15. So it has to be divisible by 4 and bigger than 15. So it's going to be either 16. Okay, but this is 1, 2, or 6. Okay, so 1 would work because this would add to 16, and the middle digit would be a 4. 2 does not work, and 6 does not work because it can't be an even number. This needs to be an odd number because wait, let me think. Yeah, so the column adds to 21. If this is divisible by 4, that means it's even. And subtracting an even number from 21 leaves an odd number, because odd minus even is odd. And so this has to be odd, so it must be a 1. And then that means that the center digit here is a 4, meaning this can't be a 4. So that's 5 and that's 4. Now the 1 goes next to a 2 with the 3 here with the 6 there. That's the order that has to go. So I don't need those gray anymore. I'm just going to mark the 3 as my center. All right, well, that worked out. So this is a 5. So that's on the side that adds to 8. And 1 is gone, so we can't do 5, 1, 2. So we're going to go 5, 3. And then this is our 4. And then, but adding to 4 and 2 would require a 1, 3. Hold on. Well, we need a 6 somewhere. Sorry. Did I say 4? No, sorry. The 1 doesn't make it add to 16. The 1 makes it add to 20. That makes a lot more sense. That's 5 times 4. So this is the 4 and this is the 5. I messed that up. So the middle is the 5. The 6 has to go somewhere. The 6 is not going to be on the side that adds to 5. It's going to be on the side that adds to 10. And that has to be 4, 6. Or 1. Well, the 1's gone. Let's think about this for a second. We've got 2, 3, 5, 6. I'm thinking this is 6 and this is 5, but I want to see if there's any other option. So we know that the 5 definitely can't go here. The 5 can't go here because that n wouldn't work. I think it just has to go in the middle, because if this was a 5, this would have to be, well, we can't have it. Oh, sorry. We can't, yeah. So if this was a 5, this would have to be 10, so that doesn't work. So this is definitely the 5. And on one side we add to 5, and the other side we add to 10. But we can't add to 5 with 1, 4, so we're going to have to add to 5 with 2, 3. So it's, yeah, so my instinct was right. I just didn't know exactly how to prove it, but there, we've got our center now. 10 and 5. All right, interesting. We got it. So 5's in one of these two, as is 6. This is a 5, 6 pair. Oh, it's vertically roped. 5, 6, 5, 6, 5, 6, 2, 3. This is 2, 3. This is 1, 4, and this is 1, 4. Okay. I'm going to put the triples up here, 3, 4, 6, and 1, 2, 5. So said the center was here or here. If this center here, if this was the center's 5. These 3 would add to 5, and these 2 would add to 10. That actually works. If this was our center, then we'd still have a sum of 5. These 2 would add to 5, and these 3 would add to 5, and that doesn't work. Oh, no, sorry, these 3 would add to 10, and that doesn't work. So this can't be the 5. This can't be the center. This is the center. This is a 4, 6 to add to 10, placing the 3. And then these 3 add to 5. This is a 1, 2 pair adding to 3, so that's a 2. That's 3 and 2. And this is our 5. All right. Well, I have my center now, so I don't need the grays. I don't think I need any of the grays anymore. This is 1, 4, 5. With the 5, one of these two. So this can't be the center, because if it was the center, it would have to be the 1 doubling to 2, but then that would mean these 2 add to 1. So If it was the 4, this isn't 4 or double 4, and if this is 5, this isn't 5 or double 5. So this is not our center. So this is our center. Its options, it's certainly not going to be a 1. It's not going to be a 2. It could be 3. This would be 3 and 3, and this would be 2, 1. So 3 is possible. If this was 4, no, these can't add to 4 or 8. So it's not 4, it's not 5. If it was 6, this could add to 6, but then this couldn't be 12, so no. In fact, this is always double green. Oh, no, it's not. If we're bigger than 4, then this is always double green. Because we couldn't double it. So I think that answers the question. I think yeah, this can't be 6 because this can't be double 6. This can't be 12. So this is a 3, which makes this either a 3 or a 6, but let's see. So this could be 2, 1. It could also add to 6 with 2, 4. So we don't actually know. We just know it's not a 5. So this is 3 or 6. We don't know which one, and doubles it. That's interesting. This is 1, 4, 6. 6 is down here. So there must be Sudoku to do, right? Yeah, these 5s look down. That places this 5, giving us 6 and 5. 2 looks down, and that can't be a 2, so 2 is one of these two. Giving us the 1 and the 2 here. Giving us 1 and one of these two. What else? 1 looks down, putting... Oh yeah, this is 1, 4, 6. Not a 6. This is one's one of these two. Uniqueness tells us that this is a 6, but we're not going to use that. What else do we have? This is 2, 4, 6. Again, bottom one's not a 6. A 1, 4 pair gives us the 2 and the 3 and the 2. That's not a 2. 1, 4, 6. So this has to be 3, and that makes this a 4. Okay, that's 1 and 4. That's 6 and 1. 6 and 4. 4, 6. Oops. 4, 1, 6, 1, 4. And we're done. All right, neat puzzle, Gene. I have never seen that constraint before. That was really interesting to think about. At first, it seemed kind of like, how am I even going to get started? But like stuff like this were good starting points. All right, cool. Well, let me know how you did. And if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.